Hello, everybody. Welcome to Factor Analysis and Structural Equation Models, a video designed to get you started on using the virtual desktop at the University of Iowa to run M+ software. So I've pulled up the course webpage here. We're going to be going through this handout, Getting Started, which I have opened up here in this other window. The first thing that we need to do is make sure that we have the VPN running in the background. If you've been a student at Iowa for a while, then you probably already have done this, but if not, you'll need to follow the instructions to download and install this program, Cisco AnyConnect. And once you have done so, you should be able to open the program and connect to the VPN. So the address to connect to is vpn.uiowa.edu. You will put in your Hawk ID, so mine is Les Hoffman, for example. Under password, it is your usual password for all things Iowa, so I'm going to try to type mine correctly here. And under second password, this refers to two-factor authentication. You can either type SMS and get a text message sent to your phone that contains numeric codes that you can enter, or if you've set up two-factor authentication via an app on your phone, which I have, you can type push, P-U-S-H. I'm going to hit OK. It has now pinged my phone. I'm going to approve the request, and it is now going to log me in. So the VPN will just be running in the background. It allows you to connect to the virtual desktop. The next step on the list, if you haven't already done so, is to map the H drive on campus to your local machine. So this step is not strictly necessary, but it does facilitate the exchange of files. That way you have access to your files from any machine, whether you're on campus or off. The H drive is a universal location. I have already done this step where the article here shows you how to do so for both Mac and PC. And so my H drive has been reconnected. It's maybe not, but anyway, it should be reconnected each time, otherwise you may have to remap it. But that's okay because I don't actually need the H drive for this particular example. One thing that I do need to have though are the files that go with this introductory video. So if you haven't done so already, let's download these files. I'm just going to stick them on my desktop for right now. Here they are. And make sure that you extract the files. So if I right click on this folder and hit extract all, it's going to create a new folder on the desktop that has the editable versions of these files. So I will be giving you a lot of zip folders in this class in this format, so it's good to get in the habit of this. So inside this folder, I have two kinds of data sets, one in Excel and one in CSV, which is comma separated values. And I have two sets of M+ files. I have input, which is syntax for M+, the .inp extensions, and I have output, which is the .out extensions. All of these M+ specific files are nothing more than plain text files, which means that you can open them and edit them using any text editing software like Notepad, WordPad, TextPad, and so forth. And the last thing that I have included for your reference in this folder is the M+ syntax guide that I had created to go with the website for my book, Longitudinal Analysis. But the first half of it is a description of how to get data into a format that can be read by M+, as well as describing basic M+ commands. And so this is included for your reference as well. So once you have gone through and gotten your VPN downloaded, installed, and running in the background, mapped your H drive if you wish, gotten these files sent someplace, we'll be able to run the virtual desktop. So if I click on this link, it will warn me that the VPN is required to connect, but it is already running in the background, so I should be okay. And because I've been here before, it remembers my information. The first time that you come to this page, it will ask you likely to provide your credentials and then download and install a program known as Citrix that will run in the background. So my computer has already gone through these steps, and so I'm ready to begin the virtual desktop. So inside the virtual desktop, there's a Favorites tab where you can mark particular apps that you visited frequently. The original apps are all available inside this tab, and you can see that there's lots of different programs that are available. You can see that I also personally do not yet have access to M+, but you should have M+ in the list here. It's organized alphabetically. So if you do not have M+ and you are part of 6249, the factor analysis and SEM class, please email me right away so that I can make sure that you get access to M+. Once you have it, go ahead and hit Details. So for instance, I'm just clicking on MATLAB here just to make a demonstration, and you can click Open, and M+ will open for you in a separate window. I actually have my own license for M+, and so I am going to use that version. But once you open it from inside the virtual desktop, it will look a lot the same. Okay, so M+ is a fairly straightforward program in terms of input and output. There's not a lot of bells and whistles. Rather than putting their energy into developing the input and output process, they've put their energy into constantly updating it to have the latest innovations in statistics and measurement. So that's one of the reasons why I like it, even though it is a very expensive program, is that it stays very current. So the first thing that we need to do is open up an input file, which is what M+ calls their syntax. You can do so from the File menu or from the giant yellow envelope here. And this is pointing to the files inside my class folder. I'm going to go ahead and move that to where I downloaded it to earlier. Here's my desktop. And here we go. And let's start with the one that is example syntax type equals basic. All right, let me see if I can make this any bigger. Change font. Yes, I can. So I like to have it in a uniform width font such as Courier New. That makes it easier, but I am going to make it bigger so that we can see it on this display a little bit better. There we go. So like a lot of programs, M+ syntax has a color coding system, but it's fairly straightforward. There's only 3 possible colors. Green is comments, and that is the same as it is in SAS and Stata. Blue is system commands that M+ recognizes, and those all end in a colon. So you'll see 4 of these, for example. Title, data, variable, and analysis are all system commands in blue. And anything else that involves options, variables, or labeling conventions are going to be just in regular black text. So M+ has a few quirks in dealing with its syntax that I wanted to make sure that you're aware of. So first, I have a series of exclamation points across the top here. Note that they stop at column 89. So you can tell in the very bottom right corner, I don't know if you can see this, it says column 89. That's because M+ input lines are not read past 90 characters. So any content that you put past column 90 will be ignored. And to remind myself of this, I usually put some sort of header on the top of my file to provide a visual barrier so that I know that any text shouldn't go past that. As you may have guessed, I've chosen exclamation point because that is how you denote a comment in M+ syntax. So for example, right here are a couple of notes with a exclamation point in the front. Those comments are notes to yourself that you can provide documentation, a description of what you're doing and why, and those notes are ignored by the program. The other thing that you need to be aware of is that any M+ variable names or parameter labels, we'll see examples of the latter later in this semester, have to be 8 characters or less. So it's very 1985 up in here with respect to that. M+ doesn't know what the names of your variables used to be because the M+ data input that it takes are just text data without variable names. It will be up to you to define the variable names within this input file. So you can rename your variables to make sure that they stay within the 8-character restriction as part of this input process. And one last convention, Any M plus command, so you'll see examples of this in black text on the lines below, must end in a semicolon. So it's very SAS-like in that regard as well. So let me see what this example file is going to do. It's going to read in some data, and it's going to provide basic summary descriptive statistics for it, and that information will go into a separate output file. So title, the first part here, this is optional. A title is simply a string of text that will repeat itself in your output file. You can have this if you wish. I tend to use these for documentation purposes, but you don't have to. You do need to have data. In the data section, it explains to M+ what your file format is. So file equals the name of the file. So M+ will only take text files as input. You cannot directly import SAS datasets, Stata datasets, R datasets, or any other kind. They have to be converted to text. It will take files with a DAT extension, or it will take files with a CSV extension. CSV stands for comma separated values. This is the version that I prefer because comma separated value files can easily be opened in Excel, for instance, so that you can see what they should look like. And all software programs that I know of can export comma separated value files easily. So inside the M+ folder that these examples came from, for instance, under M+ syntax notes, I'm going to open that just to show you this part of it. So the rules about M+ syntax, the things that I've been saying aloud, are all right here. Getting data into M+, here are examples of how to create CSV file formats using different programs. So here's SPSS, for instance. Here's SAS, proc export, and here's Stata export delimited. And I'm sure there's others that I'm missing, but these tend to be the ones that are most common. So that's the very first step in working with data, is to create a new data set in a CSV format that M+ can recognize. And one aspect of that that's very important, as indicated by the put names equals no, or the no label, no variable names in Stata, is that the data set to be imported into M+ cannot have variable names at the top. So let me show you the data that we're going to be playing with. I borrowed it from their website as one of their examples. So this is the original file. I had created it in Excel format. So it has 7 variables. I have a person ID variable. There's 3 binary variables labeled U1, 2, 3, and there's 3 continuous variables labeled Y4, 5, and 6. In order to take this data set and convert it into a format that M+ can use, I had to delete the variable names from the top. So this is a very, very important step. I can't tell you how many times I have had to troubleshoot this particular step in my lifetime. The first row of data names needs to be deleted from your CSV file. Once you have done so, you can then easily save it in Excel, for instance, as that format. Won't let me do so, of course, until it's been approved. Save as, and there's a drop-down menu where you can select comma delimited CSV as your format. I have already done that step for demonstration purposes, so example data with an underscore in between is the version that we're going to be importing into M+. And if I open that up, you can see that it looks exactly the same, except the variable names have been removed from the first row. Okay. So file equals. Note what is also not included here is any sort of path reference to where the file is on the computer. That is because when you open an input file, the first place that M+ looks for data to go with it is inside that same folder. So you can take advantage of this feature to avoid having to type out long, complicated path names by always ensuring that you store your CSV data file in the same place as you store your M+ input file. So right here, for instance, the M+ input file that we're working with, the .inp extension, that's the screen that I have open right now, is going to import this CSV file that's in the same place. So as long as the input and data are inside the same folder, you do not need a path to get to the data set. If you change it, then you would have to provide a path, such as this long one here, to that CSV file location. So example data is the name of the file. Other sub options that you can use to denote different types of files, these are actually the defaults, so they're not strictly necessary, but I include them here for completeness. Type equals individual means that it's the typical type of data set where rows are different subjects and columns are different variables. M+ also allows input of data in a matrix format, such as when dealing with summary information from a study instead of raw information. And the format of the data can either be free or fixed. Fixed format needs to have, that's where you have so many characters for each variable and it's organized by, the first 4 rows are this variable, then we have a space, and then the next 4 rows are this variable, that kind of data set in which you need to give a formatting statement for it to be read correctly. Those types of data tend to be a pain to work with, so free format in the CSV is usually the easiest thing in my opinion. So we have, just to recap so far, optional title. We have data that explains where the data are. So within the same folder, in this case, is the default default assumption, the name of the file, and the format of the file. Then we get to variable. This part is super important because, as we saw before, the data do not have variable names. So it is up to you to provide the names of the variables, ensuring that each name is 8 characters or fewer. So names, and you can use are, is, or equal. So I'm actually going to change that here to be consistent. I tend to go back and forth across my own code, but names is a statement that tells M+ the names of the variables in the CSV file in order. And this part is another very common error that students make, is not realizing all of the variables that have been included or putting the names in the wrong order. When you're working with M+, because you have to list out all of the variable names in the file, it can be convenient to subset your data ahead of time just to the variables that you know that you're going to be working with immediately. That way, this line listing all of the variable names is shorter. So I've listed out all 7 variables in the order in which they occur. The next line here, use variables, says which of the variables are going to be included in my analysis. So you don't have to use all of the variables that are in the file. You can subset them. I have R here, so I'm going to change that to equals. And I'm also demonstrating a way to create a shorthand in abbreviating the list of variables. So M+ understands this principle of numeric suffixes. I have to say that word correctly. So when it reads U1-U3, it understands that I mean U1, U2, U3, likewise 4 through 6. And so you can take advantage of this feature even if the original variables were not named as such. If you name them with numeric suffixes, then you can abbreviate long lists of variables that way, which is very handy when doing scale analysis in which you have multiple items. So note that I have not included person ID on the use variables line, because while person ID is an important part of the file, it is not a variable that is going to go into my analysis. If you forget this use variables statement, so if it is shut off as a comment or otherwise omitted, M+ will treat person ID as if it is a variable. It will try to estimate its mean, its variance, and its covariances with other variables in the model, usually causing problems. So please don't forget the use variables option. And then last but not least, you are allowed to have missing data, but you will need to explain what code is being used to indicate missing data. M+ does allow you to use blanks or dots. However, in my previous experience, this has led to problems and confusion and a lack of data being imported correctly. So perhaps for superstitious reasons, I tend to use explicit missing value codes. Here's one, 99999, which is unlikely to be observed in real data. Other people might pick -99 or what have you. You can define missing value codes to be specific to certain variables. If you'd like the same code to be used for all variables, then you can just use this keyword all and provide the one missing value code that you are going to use. So variable, just to recap, the names of the variables in the file in the order in which they appear, use variables, which variables are actually going to be part of the current analysis, and then the missing data codes that may be used in your data. Analysis is going to provide options for the estimation of a model. In this case, we're not actually requesting any models, we're simply requesting descriptive statistics, and that is what is provided by this type equals basic. So there's one more subcommand that is currently not being used here, which is model, because it's not yet relevant. So unlike other programs, in M+, you don't need to highlight chunks of text before you run it, because M+ runs the entire file every time. This means that separate models either need to go into separate input files, or you need to comment out a given model in order to run a subsequent one. So you'll see examples of the latter in this current class. I'll have one long input file where I will comment sections out in order to run separate models for separate examples. So I'm not going to highlight anything. The only thing that I would need to do if I had changed it is to save it. It would insist on it being saved before it runs anything. And then this little run icon right here in red, and a black box popped up, and here is the output. Unfortunately, the output is very small relative to what it was before. Let me see if I can get to change font. Yes, I can. Let's make this a little bit bigger so we can see it. There we go. So it prints the date and time at the top, as well as the version of M+, which is handy when making sure that your results are backwards compatible with previous versions. It echoes all of the syntax in the input file at the top of this output file. So under input instructions, it gives you everything. So what that means is that if you are sending me files for me to help you troubleshoot, you don't need to send me the input. All I need to see is the output, because the output also contains the input right here. So input reading terminated normally. Hooray! That means it did not encounter any problems in parsing your syntax. Example for introducing M+, that is the title that I provided in the input. So I'm going to go back to the window here. So here's the title that I provided that is being echoed to the output window. It tells you how many cases it read in. So this is a good way to check to make sure that your data are being read correctly, as well as the number of variables. And it does separate into independent and dependent variables within certain models, or exogenous and endogenous, as it were. It also tells you which ones are being treated as continuous. This is the default. We will not see anything other than continuous for several weeks yet. If there's an estimation method, ML stands for maximum likelihood, as well as whatever criteria are being used to establish that the model has successfully converged, the name of the file, and the format of it. So M+ output, as you may have guessed, is very long. And unfortunately, there is no way to shut off parts of the output that you don't want to see. So you'll have to get used to doing a lot of scrolling as you navigate through this. So here is where we left off. Summary of data. It gives you the number of missing data patterns. In this case, there are no missing data, and so there's only one pattern in which everybody has everything. There's 500 cases in this file. It also gives you covariance coverage, meaning the proportion of the sample that has each type of observation. So in this case, 100% of the sample has all combinations of the variables. Results for basic analysis. So this is the results that we get when we use this type equals basic here. And even if you're not necessarily interested in getting descriptive statistics because you probably already have them, this is how you will check to make sure that your data have been read correctly. If so, it should spit back the correct means, variances, and covariances for your variables. So simply as a check, I would encourage you to get summary statistics like means in the original data in the original program you're working with and verify that they match those of M+. They may not match exactly because of missing data, but they should be pretty close. So if you see something that's wildly off, that's your clue that you probably have omitted a variable in the list of variables in the file, or otherwise something has gone awry in it establishing what each column of data is to be called. All right, where was I? Here we go. So it gives me the means of each of my 6 variables. Covariances, this is a covariance matrix, which means that the diagonal of the matrix, so this spot right here and this one right here, these are variances of the variables, whereas the off diagonals are covariances between the variables. It also gives you the standardized version of that covariance matrix, which is a correlation matrix with ones on the diagonal for the variances of each variable, and then Pearson correlations here in the off diagonal. In this case, I know it's Pearson correlations because these variables are being treated as continuous. It gives you -2 log likelihood for the unrestricted model. We'll learn more about that later. And it also gives you additional descriptive statistics about each variable. So the mean, the skewness, the range, percentiles. And so in particular, checking the minimum and maximum values along with the mean can give you a sense as to whether the mapping of variable names to columns has gone correctly. And there is also a diagramming feature in M+ that gets created by default. We're not going to make use of that in this class, but it doesn't get used for type equals basic. And then last but not least, they have the address of their company, which I believe is their home address. So the Mutanes live at Stoner Avenue, or at least that's where they work. So that's that example. If I go to the other one, example syntax with model, let me make this bigger again so that we can see it a little more readily. Here we go. Here is the other input file that I provided, which is identical to the input in the previous with a few extra things added on. So let me go to change those there. I have added to this section right here. So title, data, and variable are the same. And then these 3 options here are different. Rather than having type equals basic, I have type equals general. That will be used for most of the models that we would run in this class and in any statistical analysis. There's very specific types that get used for other variants that we won't get a chance to talk about. If you want to get the same descriptive information used to troubleshoot the mapping of variables to columns, descriptives, I can't type apparently, there we go. The SAMP stat option under output will give that to you. So the output command is where you request additional information besides what is provided by default in the output file. Another thing that you can request as part of the output is a standardized solution. So in regression, for instance, we're used to working with intercepts and slopes in the raw data format. You can also request a standardized regression solution where the slopes are converted to standardized slopes that range from -1 to 1. The same is true of structural equation models, and so we will use the standardized option in most of what we see in this class. There's various ways to standardize, and STDYX means fully standardized with respect to both the Y outcomes and the X predictors. And then last but not least, under model. So what I have here is the equivalent of how to get the fully saturated model that type equals basic assumes you wanted, which means that we are simply estimating every variable's mean, variance, as well as all possible covariances between the variables. So in M+ parlance, When you refer to a variable just all by itself, you just list it, and then a semicolon is used as the command terminator. What you are actually referring to is its estimated variance or residual variance. It knows which it is to be based on the context of the model. So if you were referring to a variable that is predicted, it is an outcome with respect to other variables, then M+ will provide its residual variance. That happens by default. These statements simply refer to that estimated residual variance. In contrast, if you are referring to a variable that is a predictor, it is exogenous, but you're trying to bring it into the likelihood, then this statement will provide its variance. So it's not leftover variance in the sense of residual variance, it's original variance. So the context of the model will tell it which is which, and they will be labeled accordingly in the output. If you list a variable inside brackets, and so these are the brackets that are right above the quote sign on your keyboard, open bracket here, closed bracket here, these refer to either a variable's mean or an intercept, again conditional on the context of the model. So for variables that are outcomes of other variables that are being predicted, they have intercepts, which are conditional means when all of their predictors are 0. If a variable is not being predicted, if it's exogenous but it's being brought into the model likelihood, then it gets a mean instead, an unconditional middle value. And M+ will label those separately in the output as well. And then finally, the word with is used to denote a covariance. So it's a covariance in the unstandardized solution. It becomes a correlation in the standardized solution. And you can ask for all possible covariances among a set of variables by listing the set of variables on both sides of the with. So this single line of code is going to give me all possible covariances among the 6 variables in this model. And that's it. So I'm going to hit run. Note that it wants me to save any changes that I made to the file first, so I'll say go ahead and do that. And here's my output, again in very tiny font. There we go. So it spits back all of the input, tells me how many cases, how many variables, estimation options. It gives me information about the missing data, whether I want it or not. So we'll scroll through that section. Because I asked it for the option SAMP_STAT right here under output, it's going to repeat the descriptive statistics that we saw earlier. So the means, covariances, variances of all the variables, as well as the correlations. It's also going to give me this additional descriptive information. And it's going to give me an error. So M+ is not happy with the fact that we are asking for correlations among dichotomous variables. Let that foreshadow some of the problems that we'll run into in fitting measurement models that do not acknowledge the proper distribution of the response variables. But for now, we'll go ahead and proceed. You haven't learned any of this stuff yet, so no worries. These are indices of model fit that we will talk about. And I wanted to just simply point out the model results then lists the same information that is given up here descriptively, because what I have done is estimate a model that is going to directly provide the means, variances, and covariances of the set of variables. So that information is repeated down here in the output. The with gives the covariances, so it lists every single covariance between each pair of variables. The first column is the estimate of the parameter, so in this case it's the estimate of the covariance, the standard error for it. Est over SE, this is a Wald test, and M+, as you may have noticed here, there's no denominator degrees of freedom. So this test statistic, estimate divided by standard error, is going to be treated as a Z. And here's the two-tailed p-value up to 3 digits of precision for that corresponding Z. So a Z of 12, very unlikely. So this covariance would be declared statistically significant. It's a positive association. And we have the rest of the covariances down here, and then means and variances. So in this model, nothing is predicting anything else. Therefore, the measures of central tendency given are means rather than intercepts. Likewise, the variables variances are given rather than residual variances because we haven't explained any variance yet. And here's the standardized solution. So these are covariances that have been translated into correlations instead. And you also get standard errors for those correlations and bald tests and p-values that go with them, as well as the means and variances. If you had a model in which some of the variables were being predicted, you would also get an R-square value down here for those outcomes. And then it gives you a listing of the order in which each of these parameters is referred to internally. So sometimes when a model does not estimate and it blows up and it tells you it had a problem with parameter 12, for instance. Okay, which one is parameter 12? You would have to go down here to this tech1 output, as it's known, and scroll until you figured out where parameter 12 was. For instance, in this case, parameter 12 refers to the variance of U3, just as an example. And it also gives you the starting values that it uses for all of the parameters in the model. And that's it. And in this case, it did draw a diagram for me and save that file as part of the selection here. So this is a diagram file that we can just get rid of. So that's M+. In the examples in this class, I will give you the code that will look exactly like this, that will run each of the analyses that we'll discuss. And in your homework, you will be asked to take these sorts of examples and use them as templates to run your own analyses, either on practice data or on your own data. So hopefully this will go fairly straightforward, and hopefully everyone has access to M+ inside the virtual machine. If not, please let me know immediately. So that's all for now. Thanks for watching. And as the kids say, like and subscribe and get the merch.